let's look at some definitions of circles, and then after that, let's apply one of the important definitions, which is called a tangent line, to a circle, to a situation. So first of all, when we talk about the radii of a circle, we're talking about the distance from the center to a point on the circle. And so again, we call that the radius. The diameter of a circle is just twice the radius, because the diameter is the distance between 2 points, but it goes through the center of the circle. So say there's the center of the circle right here. The diameter goes from 1 point on the circle through that center to the other side of the circle. And so again, you can kind of see my little center point right there. There's a radii here and a radii here, which represent the diameter, or the diameter is twice the radius. A chord of a circle is just a line segment having endpoints on the circle. So here's an example of a chord. We might call that, if we had letters on those points where they intersect, we might call that chord AB. A tangent line is a line that touches the circle, just touches the circle. I'm going to try to draw a line that just touches that circle, and that point that it just touches is perpendicular to the radii at that touch point. So this is supposed to be a right angle. Because I didn't get a good tangent line, I cut off a little section here, a little secant line. But again, this is supposed to be a right angle at that point of tangency. I wish I could do a better job. I might try it one more time. Just going to drive me nuts. So I'm going to try, how about if I draw the radii first, and then see if I can draw a line from that spot, and then from this spot. So that's a better looking tangent line, and the radii is perpendicular at that point. A secant is a line that passes through 2 points on the circle. So here's an example of a secant. So, I have kind of a poorly drawn picture on the next page, but let's just look at a situation. So we're given a circle, and O is the center of the circle, and AB is tangent at B. So this is supposed to be right here, not cut through here, but just touching the circle. And so if it is, that means this is a right angle right there. And angle OAB right here is 34 degrees. And we're asked to find angle AOB, and it's a pretty simple problem, and it's because of this tangency point that causes a 90-degree angle. These two angles should be equal to 90 degrees, therefore, because the sum of the angles in the triangle is 180. So 90 minus 34 is probably 56 degrees, I think. So angle AOB is equal to 56 degrees. Okay, we're going to use the formulas for the circumference of a circle, which is its perimeter, and the area of a circle, to solve some stories, some good stories. So the formula for the circumference of a circle is 2 pi times the radius. Now remember, you've seen this before. It's because, at least I think, I'm trying to remember now, the circumference of a circle is found because we can lay the radii of a circle around its perimeter once. This is supposed to be as long as the radii. A second time. A third time. When we get, that one's actually a little bit too far, so maybe about right there. If I drew a line right up to here, I would have 3.14 times. A fourth time, a fifth time, a sixth time, and you get all the way around, you've laid 6.28 of the radii around the circumference of the circle, and 6.28 is 2 times the number pi, which is 3.14. So 2 times 3.14. So that's what this formula comes from. Some people think of it as pi times d because 2r is d. The area of a circle is found by taking pi times the radius squared. And so in this particular problem, that's the one that most people know, but there is also pi d squared divided by 4. That's also the area of a circle because the radius here could be represented as the diameter cut in two. And when you square that, you get the d squared over 4. So for this problem, you really could use circumference equals pi times d, but I'm so used to using 2 pi times r, I'll just take the 4.6 inches and cut it in half. And when you type that on your calculator, 2 times pi times, I'm going to go ahead and put the 4.6 divided by 2 in parentheses, and it tells me that the circumference of the circle is 14.45 inches. The area of a circle is pi times the radius squared, which is pi times, 4.6 divided by 2 is 2.3. So why don't we just do that? And so pi, please use the pi symbol, times 2.3 squared gives us an area of 16.6. Remember, this was in inches, so this is in inches to the second power. In our next segment, we'll talk about arcs and central angles and inscribed angles and converting from radians to degrees and degrees to radians.